Assalamualaikum grade 5. Previously we have done our question answers on notebook and our reading also of tsunami. Today we are going to read about volcano on page number 93. First I will show you a video. After that you will listen video carefully and try to understand everything that is explained in the video. After that you will do reading of this page complete up till end on the next page. Now I am going to show you a video.
In February of 1942, Mexican farmer Dionisio Pulido thought he heard thunder coming from his cornfield. However, the sound wasn't coming from the sky. The source was a large smoking crack emitting gas and ejecting rocks. This fissure would come to be known as the volcano Paracutini, and over the next 9 years, its lava and ash would cover over 200 square kilometers. But where did this new volcano come from, and what triggered its unpredictable eruption? The story of any volcano begins with magma. Often this molten rock forms in areas where ocean water is able to slip into the Earth's mantle and lower the layer's melting point. The resulting magma typically remains under the Earth's surface thanks to the delicate balance of 3 geological factors. The first is lithostatic pressure. This is the weight of the Earth's crust pushing down on the magma below. Magma pushes back with the second factor, magmastatic pressure. The battle between these forces strains the third factor, the rock strength of the Earth's crust. Usually, the rock is strong enough and heavy enough to keep the magma in place. But when this equilibrium is thrown off, the consequences can be explosive. One of the most common causes of an eruption is an increase in magmastatic pressure. Magma contains various elements and compounds, many of which are dissolved in the molten rock. At high enough concentrations, compounds like water or sulfur no longer dissolve, and instead form high-pressure gas bubbles. When these bubbles reach the surface, they can burst with the force of a gunshot. And when millions of bubbles explode simultaneously, the energy can send plumes of ash into the stratosphere. But before they pop, they act like bubbles of CO2 in a shaken soda. Their presence lowers the magma's density and increases the buoyant force pushing upward through the crust. Many geologists believe this process was behind the Paracutini eruption in Mexico. There are 2 known natural causes for these buoyant bubbles. Sometimes, new magma from deeper underground brings additional gassy compounds into the mix. But bubbles can also form when magma begins to cool. In its molten state, magma is a mixture of dissolved gases and melted minerals. As the molten rock hardens, some of those minerals solidify into crystals. This process doesn't incorporate many of the dissolved gases, resulting in a higher concentration of the compounds that form explosive bubbles. Not all eruptions are due to rising magmastatic pressure. Sometimes the weight of the rock above can become dangerously low. Landslides can remove massive quantities of rock from atop a magma chamber, dropping the lithostatic pressure and instantly triggering an eruption. This process is known as unloading, and it's been responsible for numerous eruptions, including the sudden explosion of Mount St. Helens in 1980.
Okay, grade 5, you have listened this video carefully. Now open your page number 93 and read this page. After watching video, when you read, it will be helpful for you. For today, your diary will be do reading of page number 93. Have a great day, dear students. Allah Hafiz.